does the same as the first one. This is another pooling layer. It reduces the spatial size of output of the previous layer. This max pooling layer reduces the complexity of the model by taking the maximum value within a 2x2 pixels window or filter. The output of this layer is gonna be with the shape of known 8, 8, and 64, which shows a huge reduction in image size so far. Then we are going to go to our fully connected layer or FC layer. In this layer, the FC layer takes the output from the pooling layer 2 and reshape it to -1, comma 8 multiplied by 8 multiplied by 64, as our output from last layer was known 8, 8, and 64. So the output shape of this layer is known comma 1024. Now we continue to build our model. We have dropout layer. In this layer, we drop out some neurons randomly during the training process, which this helps the model work better with new data or unseen data. The output shape for this layer is still known, comma 1024. And I also need to mention that we create this layer to prevent overfitting. Then we are going to the final layer, final fully connected layer, FFC. Here we make the final fully connected layer and do all the computations related to dot product, weights, and biases to produce the final outputs here. The output size is 10, which presents the number of classes in our dataset. So the output shape is going to be none, comma 10 between brackets. So we created all the layers in our CNN model. Right now we are going to train our model. So we set up these steps 5,000 as Dr. Wen instructed for us, and we're gonna run the following codes. I put a screenshot here. You can look at this. By doing this, I'm gonna perform the training and I'm gonna print accuracy measures. Here my steps are 5,000, and I run the codes that I talked about in previous slides to do the training. After several minutes, I got my results, and I put all my results in a line graph. As we can see from the following results, the accuracy of the model is improving and getting better and better in every step of training, from 0.22 to 0.98 at the step 4700. This means that the model is working great, and through the created CNN has learned to classify the input data with an accuracy of 98%. Look at this line graph chart below, and you show that there's an increase in accuracy rates in our model, which is a good. In this section, I'm gonna compare my results from this model with another results in homework assignment 4. The dataset there was MNIST, and the dataset that I'm using today is CIFAR. So I'm gonna compare the accuracy that results that I got from my model together. Here you can see that there's two different accuracy measures. The first one is for MNIST dataset, and it is colored with blue in my line graph, and the second one is my accuracy rates from CIFAR dataset. And you can see that the color is orange. If I want to compare these two uh, um, accuracy rates, I can see that both of them have a great accuracy at the end of the training process. But we can see that the CNN on MNIST dataset have a higher accuracy than CIFAR dataset at the beginning steps. The first accuracy in step 0 for MNIST is 0.1867, and in second step it goes up to 0.9425, which is a great result. While the accuracy of CIFAR dataset has much more fluctuation, you can see that there are a lot of ups and downs in increasing flow of accuracy rates in CIFAR dataset compared to MNIST dataset. And we can say that the MNIST CNN has a more stable trend comparing to CIFAR CNN. So I can say that the CNN for MNIST seems to be a better and more accurate model compared to CIFAR CNN. Although both models have a great accuracy at the end of the training process. Now, I want to try to improve the convolutional neural network that I made on CIFAR dataset. So I try to change the steps and increase it from 5,000 to 6,000. And good news is that now I have 100% accuracy uh, from this model. You can see the results, and if you look at the end of these accuracy measures, you can see number one. It means that the model is working perfect, and we can say that I achieved an accuracy rate with 100% at the step 6,000. The chart below shows that this model still has these two models has still both has still fluctuations, but the accuracy rate hit the 100%. That is an amazing news for us. Uh, Thank you for watching my project. So in conclusion, I'm gonna talk about what I did in my project. I made and trained a CNN convolutional neural network model on a dataset named CIFAR-10. And I achieved the 90% accuracy at my first attempt. And that's a good news because that's a great accuracy measure. But I wanted to improve it, so I changed the steps numbers. It was 5,000. I changed it to 6,000, and by doing this modification, and I improved my model to achieve 100% accuracy, which is great, and that is a noticeable result. Uh, um, I also compared my results on my CIFAR dataset, on my CNN model on CIFAR dataset with results from uh, my convolutional neural network on MNIST dataset. And I saw that in MNIST dataset there's a more steady increase flow, and that one has a higher accuracy rate rather than our first model that we built on CIFAR dataset. Uh, so here we have a great data, we have a great model, and this model can be used for image recognition purposes, and we saw that after improving the model with going from 5,000 steps to 6,000, the accuracy rate hits 100%, and this is great news. Thank you for watching my project. Have a good day.